All right, so we talked about two different ways to find the distance between points in the coordinate plane. One of them was a formula, one of them was a method that we used in Euclidean geometry before we even started using the coordinate plane. Who wants to help me with either one of those right now? Maya? What do you want to do? Okay, so Maya wants to use a distance formula. That's a formula we got by using some Euclidean geometry methods. And to find that distance, let me throw something on here first, Maya, real quick. We want to find the distance from O to A, that right there. And I'm not going to call that D. We've been using D for the distance, but D would be a bad letter to use here because when we're talking about circles, why might that cause a problem?
D is for diameter.
Yeah, D is usually used for diameter. And we're not trying to find the length of the diameter here, we're trying to find the length of the radius. So, Maya, what letter do you think we ought to use for that? That would be a good choice, I think. So instead of saying D equals, we should say R equals, and then it's the big square root one, right? All right, go ahead, Maya. Fill it in for me.
8 minus 4, and then plus the parentheses and square root, plus parentheses 5 minus 2.
All right, you guys agree with that? So you did y2 minus y1 squared plus x2, I did that backwards. x2 minus x1 squared plus y2 minus y1 squared, and then the square root of all of that. Maya, what is 8 minus 4?
4.
So we get 4 squared plus 5 minus 2 is, we get 3 squared. 4 squared is,
16.
and 3 squared,
9.
16 plus 9.
25.
So the square root of 25 is,
5.
so the radius of this circle is 5. Any questions about that? I like that way. Does anybody remember how we got the distance formula? Where did the distance formula actually come from? Yeah, the Pythagorean theorem. So the Pythagorean theorem was a theorem that works on what kind of shape? A right triangle. Where's the right triangle in this picture? It's right there? I don't see it right now. Tatiana, what do I do to draw the right triangle in? Ooh, go that way?
Yeah, that's what I do.
Okay. So I can go straight across from one and straight down from the other, and we end up with this right triangle right here. Now, we could find the radius using that right triangle also. So let's go ahead and do that real quick. What is the length of this leg right here? Why is it 3? Yeah, remember when we want to find the distance along the y-axis, we subtract the y's. That's a vertical distance there, and so we get a leg of 3 there. What is the length of that leg right there going to be? That's 4. That's going to be, where's the 4 come from? 8 minus 4 gives us the 4 for that leg. If I get rid of all this other stuff here, oop, I didn't want to do that. If I get rid of all this other stuff here and just look at that triangle, what kind of triangle is it, Tiffany? It is a 3, 4, 5 triangle. So since this leg right here is 3 and this leg right here is 4, then that means that our hypotenuse, which just happens to also be the radius, is 5. And we get the same answer, don't we? A little bit of a delay here. So either way we do it, whether we're using the distance formula or we're using the Pythagorean theorem, we get a radius of 5. All right, now let's look at an example here. In this example, we actually have the exact same circle. The only difference between this problem and the last problem is that I gave you the radius of 5, which that's really the same as the last problem because the radius ended up being 5 in the last problem. But now this could be any point on the circle. So it doesn't have to be just this point right here, but this point A could be anywhere we want it to be. It could be right here, it could be right here, it could be right here, it could be any point on the circle. And so what we want to do here is we want to write an equation that relates the radius to the center to this point on the circle. It's not as easy to do using the distance formula, although we could do it with the distance formula. I think the Pythagorean theorem way is going to be a little bit easier here. I'm going to give you just about a minute or two and see if you can get something that makes sense here. Get some sort of equation that relates the 5, the 4, the 2, the x, and the y to each other. Go. I'll draw the triangle in here. So starting at the center, I'll go horizontal line, vertical line, and then just for good measure, I'm going to go ahead and draw that part in. And we've got a right angle there. So I want to find the length of this leg right here. How would I do that? Y minus 2. Okay, Dante says y minus 2. What do you guys think about that? You had that? Why'd you erase it?
If you have to add in, aren't you gonna have an X and a Y? Can't you not have two variables?
You can. In fact, remember the y equals mx plus b equation? The equation of a line? There's two variables there, aren't there? Oh, man. Okay, so we do get y minus 2 for that side. That assumes, though, that y is what compared to 2? It's bigger, right? Because if y was smaller than 2, then we would end up with a negative. Is it possible that y is smaller than 2? In this picture, y is clearly above the center, right? That point is clearly above the center point. But remember, I said this point that we're dealing with could be any point on the circle. If I picked a point down here, then y would be smaller than 2, wouldn't it? So in that case, would that give us a negative distance? No. So what should I do? What should I do with this y minus 2 to make sure that it always gives us a distance, which the distance has to be positive, right? Allie? Absolute value, yep. So that distance there is going to be the absolute value of y minus 2. That way y could be anything bigger than 2 or less than 2, and it's still going to give us the distance. Now, just real quick, can anybody tell me what's the biggest that y could be? At what point would y be the biggest? If it's at the top of the circle, right? Anybody know what point that would be if it's straight up from the center and has a radius of 5? This radius here is 5. This is at 2 on the y-axis, so it would have to be at 7 on the y-axis, right? So the biggest y could possibly be is 7. What's the smallest that y could be down here?
Negative 7.
No.
Would it be
Negative 3. William got it first. All right. So if you start at 2 on the y-axis and you go down 5, you're going to get to negative 3. So the smallest that y could be is negative 3. So what we have to account for here is the possibility of y being anywhere from negative 3 to positive 7. And if y is less than 2, then we need to make sure that we get a positive distance there. All right, let me get rid of all that stuff so it doesn't confuse us later. Okay, how about the other leg, this leg right here? What did you say, Tiffany?
It stops with value of X minus 4.
You guys agree with Tiffany there? No?
She's upset.
She's upset?
Yeah, because she said it in the competition, so she's doing that.
I'm sorry, Maya. Do you guys agree with Maya and Tiffany on the absolute value of x minus 4?
Yeah.
I agree with them. So it's the same thing. If we want to find the distance, the horizontal distance, or the distance along the x-axis, then we subtract the x-coordinates, in this case x minus 4. And just to make sure that we get a positive, because x could be anywhere from -1 to +9. You guys see where I got those numbers? 5 units to the left of 4 would be at -1. 5 units to the right of 4 would be at +9. So x could be anywhere from -1 to +5. We have to make sure that that distance is always positive. I said +5 instead of +9. You get the idea, though. Okay, and I'm gonna put a 5 here and clean this up a little bit. Get rid of everything. Oh no, you can't read that. What that? Okay, so I need an equation now that relates all of that stuff together. These expressions that I have, the absolute value of y minus 2, the absolute value of x minus 4, and the 5, that has all of the information from the problem in it. It has our center point at 2, 4. I'm sorry, 4, 2. It has our point on the circle at x, y, and it has the radius in there. So now I want to write the equation of the line. Who thinks they can do that? I'm sorry, the equation of the circle. This equation that's going to relate all of them. Remember, the Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. Ade, what do you think?
X minus 4 and
Absolute value?
I couldn't think of it.
Okay,
Plus
hold on. You're missing something.
squared.
Squared, yes. Why do we have to square it today? Yeah, that's leg squared, right? Now, before you go any further, let's talk about this absolute value in here. This absolute value makes sure that whatever x minus 4 is, it changes to a positive. Now that we square it, do we need to really make sure that x minus 4 is positive? No. Because even if x minus 4 is negative, when we square it, what's going to happen? It's going to become positive. So let's simplify this a little bit. Let's get rid of those absolute values and just say x minus 4 squared. Is that okay?
Yeah.
Is that fair? Okay, Ade, keep going.
Plus y minus 2 squared.
Equals 5 squared, which is what?
25.
That's the equation I was looking for right there. Now, you could write this equation a few different ways. If you had the 4 and the x switched, that would mean the exact same thing. Because when we take x minus 4 and we square it, we get the same thing as when we take 4 minus x and square it. Same thing over here. If we had flipped the y and the 2, that would be okay. And these two terms here, the x minus 4 squared and the y minus 2 squared, could be flipped also. So there's a bunch of different ways it could look, but all of them mean the same thing as this. How many people had something like this? A few?
I had the exact same thing.
Yeah, I agree with mine.
What that equation gives us is all of the points that have a distance of 5 from that point O. So it doesn't just give us that one point, just that point A at, 8, 5. It doesn't just give us that point right there, but it gives us any point that has a distance of 5 from O. So when we set up the Pythagorean theorem, we weren't just setting it up for that one triangle, but we were setting it up for any triangle for the second point being on the circle. Does that make sense? So what we've done here is we've generalized it. We came up with an equation, kind of like when we did the slope-intercept form, the y equals mx plus b stuff. We came up with an equation here that doesn't give us a line, but it gives us a it's a circle, guys.
Yes. A circle.
The equation that we got, the x minus 4 squared plus y minus 2 squared equals 25, that equation describes a circle. Just like the equation that we wrote, y equals mx plus b, those describe a line. Exactly. All right, let's get our What was the first thing we did in the last problem to write the equation of that circle? We drew a triangle, right? So let's go ahead and do that here. So I'm going to draw a horizontal line and a vertical line from those 2 points, and I'll connect the points so we get our right triangle there. And I'm going to mark my right angle just so we don't forget it's a right triangle. And what is the length in this picture of that leg right there? What is it? That's a good question. So it's k minus y, or what other way could we write it? K minus y or y minus k. I'm going to write it y minus k. And technically, right now, when it's just a distance, we need the absolute values there. But what are we going to do with this later on? We're going to square it, which means that even if it was negative, it's going to make it positive, and the absolute values really aren't necessary. And right here, what's the length of that leg going to be? X minus h. So that's the distance along the x-axis. And we're also going to use this radius here. I'm going to put that in so that we can see it. And so that's what we have right now. That's our right triangle. Who thinks they can tell me what the equation is going to look like relating all of this stuff? Raven?
Would it be x minus 3 squared plus y minus 10 equals
So we have leg squared here, we have leg squared here. This needs to be
the
hypotenuse squared, right? So what's the hypotenuse? So it's going to be r squared, right? So this equation here is just the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. It just happens to be the Pythagorean theorem for that triangle, which is a triangle within a circle. So this equation right here is the equation of a circle. Now, don't write it down yet. I want to talk about this just for a second. Stay focused on what I'm saying, because this is pretty important. Earlier, we had an equation that looked like this. We had this equation. What is this equation? That's the slope-intercept form of a line, right? This equation right here makes a line. It's really important to understand that. Different types of equations are going to make different types of shapes. That equation there is going to make a line. When we wrote this equation for any particular line, which variables did we leave in there? The x and the y, right? So the x here and the y here, those stay. What happened to the m and the b? What did we put in there? Yeah, we put the slope and the y-intercept. We put numbers in there, right? The same thing is going to be true for this equation. We want the x and the y to stay in here because those are going to represent a point on the circle, but the h, the k, and the r, those are all going to go away. So what are we going to put in for h and k? Where did we get the h and the k? They were in our picture. Which point was that? One of the points had coordinates h, k. Which one was that? Was that the one on the circle, or was that at the center of the circle? You guys are both sleeping. That was the center of the circle. So if we know the coordinates of the center of the circle, that's what we're going to put in for h and k. What are we going to put in for r? That one's easy. The radius of the circle. So right here, this is the equation of a circle. And when we write the equation of a circle, again, we want to leave the x and the y in there, but we want to replace the h and the k and the r with the information from the picture. In this equation, what we have here is all of the information we need to know to represent all of the points on a circle. So this h and k here, those are the center. I'm sorry, those are the coordinates of the center of the circle. The x and the y, just like the x and the y in the slope-intercept form of a line, represent any point on the line. The x and the y here represent any point on the circle. And then the r, in this case, represents the radius of the circle. This equation here comes from the Pythagorean theorem. No matter what point I pick on the circle, whether it's the one that I've got on there or maybe say I pick this one here, that equation will be the Pythagorean theorem for that circle, or I'm sorry, that triangle. Because we're always going to have r as the hypotenuse, we're always going to have y minus k as one of the legs, and we're always going to have x minus h as the other leg. So the Pythagorean theorem is always going to work no matter what point I pick on the circle. There are a few special cases, particularly when we have a horizontal line and a vertical line that's going to be a little bit different, but as far as the equation is concerned, it ends up being the same. So what we're going to do here is a few examples in two different ways. I'm going to give you some information about a circle, and you're going to write the equation of the circle. Then I'm going to give you the equation of a circle, and you're going to give me information about that circle. We're not going to draw any pictures of circles today. We'll save all that for tomorrow. In this example, we have a circle with a center at 2, -3, and a radius of 4. If you wanted to, you could probably draw a picture of what this circle is going to look like. In fact, I'm going to do that, but you don't need to. So if I were to plot the point 2, -3, and I'm just going to sketch it roughly here. So there's 2 and -3. And it has a radius of 4. Remember what we did in the not the opener, but the first example? I said, okay, well, how high can y be? What's the biggest that y could be here? If I go from -3 on the y-axis and a radius of 4, I go up 4, what am I going to get to? 1, right? So if I go to 1 right here, I'm going to get a point right there where I had the 2 labeled. How far down could I go? -7, so I get another point there. How far to the right could I go? 4 more to the right, which would be at 6, or 4 to the left, which would be at -2. So there are 4 points that are going to be on the circle. So what we're trying to do here is we're trying to write an equation that represents that circle. It's actually easier to write the equation than to do what I just did. Anybody think they know what the equation is going to look like? A day?
I did how we did the first one, the x minus 2.
X minus 2?
Squared
Okay.
plus y plus 3 squared.
Okay, good. Why did you do plus 3?
Those two negative.
Yeah, so it's y minus k, but in this case, k is -3, so h is 2, k is -3. So what we would end up with is y minus -3, which is, as Ade said, plus 3. Very good. Equals what, Ade?
4 squared is 16.
Perfect. So this equation right here represents that circle right there. Pretty cool, huh? All right, another one. So now we want to write the equation of the circle with center at -3, 7 and a radius of 4 square root of 2. I'll give you a minute to do that. You did the last one today.
Doc got his hand up.
Don does? Don, do you have the equation? Okay, go ahead. Read it to me.
X plus 3 squared plus y minus 7 squared equals 32.
Perfect. So again, when we had a negative coordinate right here for x, that's going to be our h in the formula. When we had the negative, x minus -3 is the same as x plus 3. We wouldn't want to put the double negative in there. We'll just change it to a positive. And then 4 square root of 2 squared is 32 because 4 squared is 16 and the square root of 2 squared is 2. 16 times 2 is 32. Question?
So that's all the math we have to do for the radius, because we're just plugging that in.
Yeah, for this problem, this particular problem, yep. That's all you gotta do. Pretty easy, right? Okay, last one, like this. Find the equation of the circle with center 0, 0 and a radius of 1. Okay, who wants this one? Somebody, William, go ahead.
Wouldn't it be just x squared plus y squared equals 1?
Do you guys agree with that? I do. How many people had that? Okay, 3 of you. Not bad. Why, William?
Because x can be subtracted. 0 can be subtracted from x. Does that make sense?
Yeah, I know what you mean by that. So when we just plug all this stuff into the equation, we get this. We get x minus 0 squared plus y minus 0 squared equals 1 squared. Well, what is x minus 0? What is that? That's just x, right? So since x minus 0 is just x, this is x squared. Since y minus 0 is y, we're not taking anything from it, then we get y squared. And 1 squared is 1, so we get 1. So the simplest way to write this equation, and we always like to write things as simply as we can, right, would be x squared plus y squared equals 1.
So when you want to run it like,
I would expect you to write it like the top one. Technically, this would, if I were to graph something like this, like if I were to type that into GeoGebra, it would give me the same thing. But we want to write it as simply as we can. Okay, so now we're going to go the other way. This is the equation of a circle. And I want you to use this equation of a circle to tell me what the center of the circle is and what the radius is. We'll do the first one together here, and then after the first one, then I'll let you do the other ones on your own. I'm going to call the center of the circle point O. So I'm going to use a capital O here for the center of the circle, and I'm going to call the radius little r. What would be the coordinates of point O, the center of the circle? Raven?
2, -5.
Okay, and how'd you get that?
Because H and K is what 2 is and 5 is positive, so that means that it was negative.
Yeah, exactly. H and K are always going to be the opposite of what you're adding on to x and y. Because the formula has a minus there. It's x minus h and y minus k. So if you have an x minus something, then it's going to be a positive x coordinate. If you have x plus something, then it's going to be a negative x coordinate. So you always just want to take the opposite of what's with x for the x coordinate, the opposite of what's with y for the y coordinate. And what's the radius here going to be? 6. How do you get 6? Square root of 36. Good. Okay, how about this one? What do we get for the coordinates of point O? A day? 0 and 7. And I think when you say and, you mean comma, right? Okay, yeah. So 0, 7. And don't forget the parentheses. And how about the radius? Somebody else? Kaylee, what'd you get for the radius? 7. You guys agree with that?
Yeah.
Do you think that you could take this and draw a picture of what the circle looks like? Kinda, sorta?
If I had GeoGebra.
Well, that'd be even easier. Then you wouldn't even have to do this. You could just type in the equation, right? Let's say you don't have GeoGebra, though, and you just want to do it by hand. You could plot the center of the circle, and then from the center go up 7, down 7, right 7, and left 7. That gives you 4 points on the circle, and then just draw the circle through those points. All right, last one. What's the catch on this one? Brittany, did you say you caught it? No? Allie?
He flips the y and the x.
Yeah, I flipped the y and the x. So in all the other equations, we had x here and we had y here. So Allie, how's that going to affect our center? What should it be?
It should be 8, -2.
Perfect. So the x coordinate is always going to be the opposite of the number that's with x. So since we have x minus 8 squared here, that's going to be the x coordinate of the center. And then the y coordinate is going to be the -2. How many people got that? Okay, cool. And the radius is going to be the square root of 20, which we should probably reduce that or simplify that, not really reduce it. And we get 2 square root of 5. This one would be a little bit trickier to graph because I don't really know how far 2 square root of 5 is. I would probably have to type that into my calculator, get an approximation, and then add and subtract that from the x and the y coordinates. How you guys feeling about this?
Easy.
Easy? Okay, cool.